Hello. This will be a demonstration of Proposition 5 from Book 9 of Euclid's Elements, which says that if the product of two numbers, one of which is cube, is itself also cube, then the other remaining number will be cube as well. Lots of cubes in the enunciation, so it might be a bit confusing, but let's break it down. We're given two numbers, A and B. Their product will be the number C. So A times B makes C. We're also given that the number C is a cube number. Furthermore, the number A itself is a cube number as well. And what we want to prove is that the third number, B, is also a cube number. We're going to begin by taking the square of A, call that D. So A times A, that is A squared, makes the number D. And because the number A, we were given that it's a cube number, and we know from Proposition 9.3 that the square of a cube number is also a cube number, then the square of the cube number A, D, is a cube number. Now, we recognize that the number A has been multiplied by two numbers, A and B, to make D and C respectively. A times A makes D. We've made D in that way in our first step, and A times B makes C. We were given that. And we know from Proposition 7.17 that if a number multiplied by two numbers makes two products, then the two numbers multiplied are to each other as the products, so that because this is true, A is to B just as D is to C. Now the two numbers D and C are both cube numbers. We know D is a cube number from step 2, and we know C is a cube number from our given. And we also know from Proposition 8.12 that between two cube numbers there are two mean proportionals, so that because both D and C are cube numbers, there are two mean proportionals that fall between D and C. But we also know from Proposition 8.8 that because D is to C just as A is to B, and two mean proportionals fall between D and C, then two mean proportionals also must fall between A and B. That's what Proposition 8.8 tells us. So there are two mean proportionals that fall between A and B. But we know from Proposition 8.23 that if two mean proportionals fall between two numbers, and one of those numbers is a cube number, then the other number also is a cube number, so that because there are two mean proportionals between A and B, and the first number A is a cube number, then the last number B will also be a cube number, which is what we set out to prove, which means we're done with the proposition, therefore, etc., QED. This was, just as a note, this is the converse of the previous proposition 9.4. Now, with that said, I do want to just give an example, of course. The cube number 8 times the number 27 makes 216. We know 8 is a cube number because it is 2 cubed, and we know 216 is a cube number as well. It is 6 cubed. So what this proposition allows us to say is that 27 itself is a cube number, and that's easy to verify. 27 is equal to 3 cubed. So we see that this proposition holds. That's all I've got to say about this one, so I'll end the video here and move on to Proposition 9.6.